Device. Oh, we're live. All right. Hey everyone. Welcome to the Android Study Jam session 2. My name is Shubham Gupta. I'm the Android Study Jam facilitator for DSC PS University Ring Road campus. So this is a collaborative session between DSC PS University Ring Road campus and the Electronic City campus. With me, I have Irfan, who is the Android facilitator for the Electronic City campus, and we have Devansh, who's
Hey
a
guys.
core member, of the Ring Road campus DSC, and he'll be our guest presenter for today. So to start off today's session, if you're able to view this stream, you're pretty much set for today, and you need to be a bit familiar with GitHub. So other than that, yeah, you won't be requiring much. That's pretty much the prerequisites. And a couple of things to clear up from the previous session will be in order for us to evaluate your progress and give you the certification, you will require to create a developer profile. So what a developer profile is, so as you can see on my screen over here, I've logged into my Google account, and yeah, I can just click on developer profile over here. Oh, yeah, it's the same thing. Sign in once. Just a sec. So what you want to do is completing each pathway gives you a badge. So as you can see, these are badges here from the completed pathways I've done. And for the certification, you need to have 10 badges from the Kotlin fundamentals. So as you can see, I've completed only 6 of them, but for the certification, all of you must be completing the 10 the 10 pathways, and in in the middle you'll
Shubham,
be.
please share your screen.
Wait, I'm not sharing my screen. Oh, I'm so sorry. Didn't realize. So yeah. Okay. I missed a bit, I guess, but that's fine. Didn't not a lot. So yeah, as you can see, you click on this button here, and it takes you to your Google developer profile. On your Google developer profile, you'll be earning a bunch of badges, as I mentioned again. So in order to get the certification, you require all the 10 Kotlin fundamental badges, and you'll be earning additional badges on the way. So yeah, that's the developer profile. And yeah, for the certification, you need the 10 badges, like I said, and you need to build a single app. So this app could be anything you've learned along the pathways. So an example app would be a to-do list app. So you can add a recycler view, a scroll view, and a button. So every time you want to add an item to your recycler view, you can click on the button, and an item would be added. In case you click on the item again, it can be removed from the recycle view. So this is just an example. You guys are free to build any sort of app you're comfortable with. So yeah, that's clear. So for today's session, we'll be going through the prior programming experience, which is the certification course. We'll be doing unit 1. So unit 1 is basically comprising of 5 pathways. The 5 pathways are, initially we're going to tell you about, we're going to recap about, the Android Studio, the project, how everything looks, all this. And then I'll be shifting over to layouts. In layouts, I'll talk about the constraint layout, a bit about styles, and, why you should be using layouts in your Android application. After that, Devansh will take over, and he'll cover the build an interactive app pathway. It's a simple, you could call it a simple app, which you learn about resources and buttons, And finally, Irfan will be covering navigation and fragments. So yeah, that's content for today. And yeah, so let's get started on Android Studio. All right, before we go into Android Studio, in the last week's session, we covered all these concepts. And in case you're not familiar with them, we'll just go through them again. I'll do it as you know, as I use them. Uh, so yeah, uh, Kotlin koans. So to understand Kotlin koans, I mean, the reason why they're present in this course, it's just to get you started with, Kotlin, in case you're not familiar with the language itself. So as you can see over here, you have a basic starter code. Let me revert that. So yeah, this will be a starter code, and they'll give you a little bit of hint on the side, and you're supposed to complete the code. And if you complete the code, you've basically completed this koan. So there are a bunch of them. You can do them at your own pace. There's no time limit for this, and this is not part of the certification course. It's just like an additional add-on so that you're comfortable with the language Kotlin, because that's what we'll be using throughout all the pathways. So yeah, that's pretty much Kotlin koans. I would recommend you guys to get to collections or conventions. Yeah, collections then. Yeah, try getting to collections in order to at least complete unit 1 of the new to programming experience. So yeah, that's Kotlin koans. uh Kotlin playground is something we used last week. So in case you want to mess around with your own code and you don't want to do pathways, you don't want to do koan specifically, uh Kotlin playground is a nice place to start off. So in case you want to just print your name, if that's all you want to do. uh Hello. Yeah, you can write any code you want over here in Kotlin and execute it, and yeah, it'll do it. So that's what Kotlin playground is. So going back to the slides. All right, now we'll jump into Android Studio. So let me close this project. And so yeah, in Android Studio, when you're creating an app, you always have to select a template. All right, so over here, you can select from a bunch of devices. We'll be sticking to phone and tablet, and under phone and tablet, we'll go on with the empty activity because we want to build an app from ground up, right? So we don't want, a button or a navigation bar or any of the other activities present. So just a simple plain empty activity will do. Session, I'll just call it a name session 2. And package name can be set to default. You don't have to worry much about package name right now. Make sure your save location where you want your project to be stored. And yeah, language is pretty important. You want to set this to Kotlin and not Java, because that's the whole point of this course. And minimum SDK again can be set to default. And yeah, you see this checkbox over here. Basically, Android used to have a bunch of libraries called android.support, but they're outdated right now and they're replaced by a bunch of libraries called Android Jetpack. So Jetpack extends Android support libraries, and they have a bunch of their own. So you don't really need legacy Android support libraries anymore. So yeah, just make sure all your settings are fine and finish. So it's going to take a while. The Gradle build I'm guessing will take a while. Let me just see. All right, nope. Everything's being done. All right, so to start off with Android Studio, I'll talk about the window first. We'll go over the project view. Yeah, so by default, the project opens up in Android view. What Android view basically gives us is, it sorts all the contents of the project based on, usability. So suppose you want to access the manifest file of, the project. You go to the manifest folder, you get Android manifest. You want to mess around with the business logic of your app. You go to Java. You select the package name, and you'll also notice that there are test folders over here. I'll explain what test folders are in a bit. But yeah, you go to Java, you go to package name, and you select the name of your layout or name of your activity. So by default, we call it activity main or main activity, and it has a bunch of pre-written code. Uh, I'll explain what this is. I'll come back to this in a while. So as you can see over here, we have some test what do you call it, test folders. What test folders basically provide us with is suppose you want to test if you've added a functionality called addition. So you can see you're trying to add 2 plus 2, and what you want to do is you want to make sure that this functionality works. So you pass the input parameters along with the expected result, and if it's correct, it'll pass. Otherwise, your app is going to crash over here. That's what assert equals to does. So yeah, this is basically unit testing for your app. You don't really have to use this right now. You can use this later on. Next we have is the resources folder. So resources folder is again subdivided into drawable, layout, map, and values. Drawable is a bunch of images you can add to your app. Layout contains the user interface of your app. So by default, you have only one XML file, which is activity main. I'll come back to this later. This whole window is called a palette. And then we have map. Map is basically the app's icon. So there are different sizes of the icon based on what device you choose. The Android device will select one of these icons and put it up. And finally, we have values. So under values, you define literals or constants. So over here, you can see purple 200 is basically a type of purple, and this is the hex value. So in the future, if you ever refer to the string r.color.purple 200, you're basically referring to this value over here. So the same with strings. You do r.string.app name, you'll get Shubham session 2. That's what it'll be referencing. And themes basically define the theme of the app. By default, we're not going to touch this. We're going to let it stay. So that's entirely under the app folder. Now we'll look at the Gradle. So coming to the Gradle, there are only 2 most important files. Everything else you might as well ignore for now. So the first one is called the project Gradle file. So project Gradle file just defines what all plugins you'll be utilizing, and yeah, you won't be messing around with this much. Wait, what have I done? All right, let it do in the background. So yeah, you won't be messing around with the project Gradle file. Instead, what you will be working with is the module Gradle file. So in the module Gradle file, you'll be defining these these libraries in the form of implementations. So any dependency you want to add, so you want to add Timber, which is a logging dependency. You can just say implementation, the path to Timber, and yeah, and then you'll have to sync it again. So once you sync it again, the implementation is added to your file, and yeah, you might as well use Timber now. So yeah, this is actually the Android view. The second view we'll be looking at is called project. So project is a bit, what you might see if you open your files in the Windows Explorer. So you have all the files just lined up like that, and you'll notice that the folders actually go pretty deep. So in case you want to access your activity main.kotlin file, you have to go to app, you have to go to src, you have to go to main, Java. Finally, you get to main activities. So In a way, you could say that the Android view, flattens out all this for you, flattens out the view or the folders, and it makes it easier to access. So you could call it a personal preference, using the project view or the, what do you call, the Android view. But yeah, uh, over here you have the gradles. But yeah, so yeah, the Android view provides a much more flatter view compared to the project overview. Apart from that, the files are the exact same. Uh, let me explain the Android manifest. I went over it. So the Android manifest file, links your Kotlin file and the XML file together. It brings it all. You could say it brings everything together. So in case you want to define, the app's launcher icon, you define it as android.icon and a reference to that. In case you want to change the app's name, you change android.label. It'll change. Wait, let me get a AVD running. So yeah, this basically defines the initial workings of your app. So here you have activity Android name main activity. What this does is, by default, when you launch an app, you want at least one activity. You want one activity to spool up, right? You don't want your app to just be doing nothing. So wait, this is my last week's. Right. So you want one activity to pop up when you start the app. So over here it's called main activity, right? So main activity is by the default hello world that's present. So when I click on my app, it launches. So this working is implemented using two keywords, main and launcher. So main tells it, this is the first activity you'll be getting started with, and launcher tells it every time you click on the app, this is the, what do you call, the layout which will be started up. So that's pretty much the working of what do you call, the manifest file. Next, moving on to layouts. I actually didn't mention this, but right, yeah, the palette. So the palette is used to design the user interface of your app. So as you can see, you have a bunch of options available you want to put. So yeah, by default, when you create an app, you're given a constraint layout and a text view which says hello world. But say you want to add some more. I want to add another text view over here. Let me just add that. Now I want another text view over here, and maybe another over here, and another over here. So you can see it's pretty simple to use the palette. Whatever you want, you just drag and drop it, and it's there. Constraints. I think I haven't defined the constraint. That's why I'm getting an error. What does it say? Yeah, missing constraints. So I'll define this in a while. For now, let it just be there. So yeah, that's the functionality of the palette. You see, you can drag and drop views based on whatever you need. And to my right over here, let's say I select hello world. You can see all the attributes of the hello world text view over here. So you can give it an ID. Let me give it an ID for now. Text view 1, right? I'll call this text view 2. Yep, refactor that. Oh, okay. Let me cancel it. Text view 2 already exists, so let me give it text view 6. That should work. Yeah. So I have text view 1, 6. There should be 3. Oh, never mind. There should be 3. There should be 4. Oh, this is okay. This is 3. This is 2. This is 4. Fine. So yeah, you can drag and drop views from your text from your palette to your user interface, and that's the main functionality of a palette. Now, let me go back over here. Let me see, did I miss anything? I've explained activity, I've explained resources. Resource, I'm not going to go too much deep into it because, again, Devansh is going to pick it up. But yeah, I've explained the Android manifest and Gradle file. Okay, Gradle file is there's a little bit more to explain. Uh, so the reason why Android uses Gradle files is you would have noticed we're using two languages right now. We're using XML and we're using Kotlin. Let me get my Kotlin code up. Right. So if you want, you want to compile multiple source codes together, you can't just do that. You can't have multiple compilers. Instead, you make use of a Gradle build tool. So what a Gradle build tool is, you take all your source code, which is your Kotlin files, you take your resources, which is your XML files, and you pass it to the compiler. The compiler will take all the files and create a DEX file. uh, to understand what a DEX file is, it's a binary file. It's something that we cannot see, but uh, it's understandable to the compiler. So once you create a DEX file, to create a APK, which is your app, uh, what you do is you pass your DEX file to your APK manager along with your and the APK manager takes your debug or release key store. So in case you guys don't know what a debug or release key store is, let me show you that. By default, when you click on yeah click on apply changes and restart activity, you're actually using your debug release store.
I think something happened to his internet. I think we'll move on and we'll get back to him when he comes back.
Yeah, so I'll be taking over now. So, hey guys, I'll be covering the second pathway, which is building an interactive app. But we won't be going through each and every step because that's what you have to do. And I'll be covering the concepts which you require to do that. And so let's start without wasting time. So yeah, these are the topics, a brief overview which I'll be giving off. So the first one is the activities. So Subham has mentioned earlier the other time. So what an activity is, I'll show it in the app as well. So what you see here is a layout file, and it's a layout of an activity. So activity, you can say it's just a single page of your app. So yeah, so when I say a page, like your app can have more than one page. That means more than one activities. And if it has more than one activities, then the system should decide which is going to be the launcher activity. And as Shubham mentioned, it is decided by your Android manifest, like which is going to be the launcher activity. If in this case we only just have one activity, so it's pre-decided that okay, the main activity is the one which is going to be the launcher activity. So this is what you see when you go on opening your app for the first time. So yeah, next we have resources. So yeah, resources are additional files and static content that your code uses, and you can find them on your left palette side. This is what the resources is written in the short form res, and you can see that the layout file which is pre-opened is also part of the resource. and you can find it by clicking on that triangle right there. It's written activity main. So this is the file which is already open for us. So these are the different values, and I'll be showing you how the resources are actually used by a code. So what Android does is it creates an R class, and the R class is a dynamically generated class. So that means the R class is does not exist automatic. It does not exist beforehand. It is created at the time when you hit the run button, right? So but you know that it's going to be created, that's why you can pre-reference it. So you can see that in the code which you get when you open the app, there is already a reference to the R class, and that is what we are doing for the layout. It's basically saying that when the app is about to run and the onCreate method is called, you have to inflate the layout. So it calls on the layout, and it does by saying that okay, all the resources have a reference in the memory, and that is done by the R class. So if you want to access a drawable, suppose, then you'll do it by saying R, which is for the resource, dot drawable, and then inside of it, whatever resource you have, sometimes you have a background, a custom through the R class. And similarly for the layout, which you are already doing here, it's R dot layout and then activity underscore main. And yeah, so moving on, uh, this R class, some use cases which I'll tell you later also is like when you have to place a button and then you want to reference it in your code, you'll again use the R class. So here I've mentioned few cases: r.id, r.drawable, r.color, and r.layout. So yeah, I'll go again and revisit this concept about views. So basically what Android understands in the layout file is everything is a view, everything which you can place, and basically these are all the building blocks of your UI element. So what UI is basically what the user will see and probably will interact with if it's a button in case. So the user has is a view, and even though if it's a button, you call it a view because that's how the classes are divided in Android. Yeah, so the views can be of different type: text view, image view, buttons, and you can find more of the views if you switch on the design tab. And then on the left hand side, you can see that the common views, which are the first three one are the common views, the text view, button, and image view. And if you want to go deeper into the text, you can switch between the text and the buttons and all of that stuff. So whatever you see here with an underline, okay, the here it's AV written with underline, that means it's a edit text. That means you can actually take a user input with all of these, and depending on the type of input you're taking, if it's a email address input, then you have to choose this one, and then just drag and drop it there. You can go ahead and drag and drop if it's a constraint layout, but if it's a linear layout, it's kind of difficult to arrange stuff, and I'll be showing you how. So next we have view groups. Now basically I like just told you that everything which you can place on the UI element is a view, but to hold the views together, you have to bind them together. So you need a view group for that. So what you can see here, which has a gray shadow, that is a view group, and inside that you have two views. The first one is a text view in which we have written hello world, and the second one is the button. So these are the two views, and the way you do that is like you first define a tag, which is the way you define it in the XML language. It's kind of similar to HTML in a sense of the way it's the syntax it's written. And these are the properties and property key and property like property and value pairs, to be precise. So first you define a view group, and inside that you place text view and button. So our linear layout is a view group, and it could be different, like it could vary a lot. So the default which you're provided with is the constraint layout, and the one which we are using here is the linear layout. Yeah, so and frame layout, you can go ahead and research in like what kind of different layouts are there according to your need. So linear layout can be in two different forms. One is the vertical one, which you can see here. Here also it's vertical, and the way you set it is defining its orientation. So its orientation can either be vertical or horizontal. And yeah, so for each view there are few properties which are similar, very very similar. If you can see, uh, not similar, it's exactly the same. These two which you can see, layout width and layout height. So you can define it for every view. Match parent basically means it will cover the whole width or height depending on if you're setting it for the width or height. Like for example, here we are setting the layout width, to match parent, and the layout height is wrap content. Wrap content means it will uh, only take as much space as it's required for the view to hold, like just to cover the full part of it. Yeah, so moving on, how do you reference the view into your actual code? Like how do you want, like if you want to do something dynamically, like you want to, make a toast or something like that. For that, here you have placed all of this, and basically these are static. Okay, these are not going to change until you add some code to it or you reference them in your actual code. And the way you do that is by first finding it in the view. So if you just have these two lines in your code, that means okay, the view is somehow attached to your code, but then you have to find the specific view for which you have to define an interactivity. And yeah, so basically what we are doing here is we are first finding the button in the view, and it's done by the function which is called find view by id. And there are many different ways in which you can write it. One of them I'll show you here. So this is Kotlin's way of type in inference. Like basically it doesn't need a type, but here, like I'll show you how. If I just remove the button from here, and you can see that it's showing an error because it doesn't know what kind of type we are storing in this variable role button. But if you define here button, then also it works. So it now knows, okay, this is a button view which we are storing. We are basically referencing a handle to the button inside our code. And then we can go ahead and use that to set like an on-click listener on it. I'll be covering that in a minute, what an on-click listener is. So find view by id is the traditional way of finding views in your code, but there are many different ways also. The one which is mostly used nowadays is view binding. And like you don't need to know it now if when you're starting out with your Android app dev, uh, but later on to make your code run faster at the low level memory side, it's recommended that you use view binding. Yeah, so coming on to the set on click listener. So like I told you, like if we want to add interactivity and we want to do something when the user presses the button, so that's when you set an on click listener to it. It's always listening. Okay, you can just think of it as someone who's always listening for a click event, and it will react as soon as the button is pressed. So what have I written here is just referencing the handle and then setting an on click listener to it. And basically, if you would have done it in Java, there is a proper function for it. And when I say function, that means you have to pass in some parameters and it's going to return something and all of that stuff. But here, what you can see here, it's just we have written that set on click listener, then we have started off with a parenthesis, curly braces, and then whatever we want to do is written here. So you'll mostly see these kinds of expression when you're switching to Kotlin, and the reason is because Kotlin expressions. And what a lambda expression is, it's kind of similar to an anonymous function concept. So it's not like a proper function which you're calling, but you're just getting its functionality at the bare minimum. And yeah, so the syntax is written here, and you can see that this it colon view which is written, which is the default reference to it. Every time you define a lambda expression, Kotlin will give it as it will be written here as it view. And just as an example, I want to show you that if you by mistake change it to another line, the braces, it's going to show you an error because then it won't understand that this is a lambda expression. So make sure that you always could be here, place here, that doesn't matter. Okay. So now if you just go and run your app in your emulator, as I have, uh, so we'll wait for the Gradle build to finish. Yeah. So just now you can see that this was our layout, which we can see is pretty much the same. This is the text view, this is the button. And if I click on the button, nothing happens now. Because if you go and see all of the stuff which I have to do is commented out, nothing is happening right now. Yeah. So I'll go ahead and uncomment it. So yeah, what you can do is you can go ahead and add few of the feedbacks option. Yeah, just a sec. Yeah. So so when you when you want to present your user with a feedback, you can go ahead and either use a toast or a snack bar. So a is something that we have to go through first, and then we'll understand. But these are both ways of providing feedbacks to your user. Significant difference between the two. Toast is just a simple message you want to show it on your screen, and the user cannot respond to it, even if it will appear and go off. But a snack bar, how it looks like,
Hey everyone, sorry about that. I'm not sure how I got disconnected. I was pretty much here. So I'm guessing apparently I disconnected 15 minutes back. So I'm guessing I was still explaining uh, the Android Studio overview and all that. Uh, so I'll just summarize it. I've actually done quite a bit of work over here as well. I'll go through that in a while. Uh, So yeah, the project has two views: the project Android view and the project view. You mostly will be using the Android view. The project view is just is the default way. If you open your file explorer, and you uh, go to that specific project, that's how project view displays it. And so yeah, that okay. I'm actually not sure from where do I restart. Let me. Anyone can tell me. Uh, I'll just do the slides again, actually. Uh, so overview of Android Studio, we have the Android Manifest. Android Manifest basically tells us, which is the default activity to run when the app starts. The default icon of the app, the name of the app, all that, and you can also define your style of the app over here. Not the style, the theme of the app, and yeah, that's basically the working of the Android Manifest. The Gradle files is a Gradle file basically tells you all the dependencies your app will be utilizing, along with the Gradle build tool is actually something that you need you need, every Android project needs. So to understand the Gradle build tool, uh, so yeah, you take your source file, which is your Kotlin files over here. You pass your XML files, which are all the strings, the activity main, the themes. You all pass it to the compiler, all right? And once you pass it to the compiler, you get a dex file. So what a dex file basically does is it's like an intermediary version of your app. You can't run it, but you can compile it further to get an get your Android application APK. Right. So to convert your dex file into your APK, you need to pass it to the APK manager. So what the APK manager does is it takes the dex file along with a key store. What the key store does is it's a, you could call it a lock and key mechanism. It binds your app data with a certain signature which is unique to you, and it creates an app. So, in case you want to publish your app to the Android, I mean, not to the Play Store, you're going to create a signed APK. So, let me show you how to create a signed APK. That's something you'll need. All right. Actually didn't realize that I was offline, so I kind of wait. Where is it? Build. Right. So yeah, I think while I was disconnected, I pretty much made a app debug APK and a release APK, but I'll just go through it. I'll just explain the steps, and yeah. So you select APK, you go over to the module. You select a key store. In case you don't have a key store, you say create new. You can give it a name. Say, wait. Yeah, give it a name. Give it a password. You might want to keep the alias a bit different from the key store name. Give it another password, and by default, all key stores require some sort of certification. So just give your first name and last name, and that should be enough. So yeah, once you've created a key store, you click on next. You select the type of APK you want. In case you are trying to publish it to the Play Store, you select release. You select V1 signature and V2 signature, and you click on finish. So I won't be doing this again. I've actually already done it here. Let me just show you the final output. Let me just go to, what's all this? Android Study Jam. What's my name? Session 2. I'll go to build, not build. I'll go to, should be an app, release. So once the process finishes, you go to this location and you'll get a release APK. This is something you can publish to the Play Store. So yeah, coming back, I think I missed out pretty much on layouts as well. So I have to explain layouts all from the beginning. So wait, let me just see. I'm connected. Yeah, yes, I am. Layouts are view groups which tells the user interface how to arrange the views inside them. So an example of that would be this. Here we have a constraint layout and we have a bunch of text views in it. So the constraint layout is actually a special one. You can pretty much arrange your views anywhere you want. And that's also the reason why you should be using it. In case you use, a linear layout, you'll have to create one linear layout just for a horizontal set of views, then another linear layout for the next set of horizontal views. Like that, it gets really complicated. So constraint layout, on the other hand, it lets you place your views freely anywhere. And yeah, that's a summary of constraint layout and why you should use it. What are constraints? So a big feature about constraint layout is the constraints. So over here, you can see we have a constraint widget. I've already defined 16, 16 here, but by default, you get everything as 0. So what it does over here is you're telling the user interface you want 16 dp of margin, at the top. You can give 16 dp of margin on the left and right, and 16 dp of margin at the bottom. So this way, you set it up in the middle. Now, suppose you don't want your view to be in the middle and you want it a bit shifted to the left or right. So you would be using these constraints called a bias. By default, you have only two biases, which is the vertical bias and horizontal bias. So say you want to shift your view a bit to the left or right, you just use the horizontal bias and shift it around. In case you want to move your view up, top or bottom, and then set it up, you change your vertical bias. That's pretty much the definition of biases. And yeah, another type of what do you call constraint is called the baseline. So to explain you guys what baseline is, let me just add another one here. Okay, and now suppose I want these two to be aligned. Okay, by default, let me keep one higher, one lower. So in case I want the I want both of these views to be horizontally parallel to each other, I'll just do show baseline. I'll connect the baseline of this text view to this one, and you can see it automatically, aligned it over there. So now, whatever happens, these two views will always be horizontally parallel to each other. So you can see I move it here, the other text view also comes down. I move it here, it comes down. I move it here, it's already there. So yeah, that's baseline. And in case you want to undo these constraint, you just you right click on it and you do clear constraint, and this view is free of the other view, and yeah, it's free. So that's baseline constraint. And right, chains. So chains is something what I was explaining is, and that's also when I realized I've disconnected. But so chains, to understand chains, okay, wait, I've already made a chain over here. Let me clear constraint selection. Where are these two? Clear constraint selection. Clear constraint should basically have no constraint at all. Okay, these three views are independent of each other. And now suppose you want to align these views in any orientation. You use the app that's horizontal or vertical, or landscape or portrait. You want all these views to be aligned in the same manner as they are. That's when you bring in what do you call chains. So to create a chain, you first select all the views you want in a chain. So I want these three views, and then I will select chains. Oh, one sec, why is it disabled? Let me select them again. Right, create a horizontal chain. I can do either create a horizontal chain or vertical chain. For this example, I'll just create a horizontal chain. So yeah, so I move any of the text views anywhere, the other views are going to come along with it, or at least that's what I thought, but apparently not. That's a bit strange. That shouldn't have happened, but okay. So what you want to do with a horizontal chain is basically you want them to be equally spaced horizontally, and so you can place them top or bottom anywhere you want, but you can't move them left or right. That, as you can see, I can't shift this anywhere else. I can only shift it top or bottom. The same with this view, it can only go up or down, but I can't move it left or right. So that's a horizontal chain. Now by default, chain uses a type of distribution of spaces called spread, I think. Wait, let me open it. Yeah, by default it's called spread. So what spread does is, you see all the space over here, it's equally distributed. So the amount of space over here is same as the amount of space here, and the amount of space here is the same as the amount of space here. So it's equally distributed among, the space between the views. Instead, the other type of way to distribute the space is called spread inside. So what spread inside does is, it uh, sets the space between the head and tail of the chains to 0, and it distributes the space equally between, the remaining views. So here I have only a single view, so hence, this space is equal to this space, and yeah, again, I can move it top or bottom, how much ever I want, but I cannot move it left or right. So it is fixed, this space over here. So that's spread inside. And finally, we have uh, something called packed. So packed is pretty much, you could call the reverse of this. Uh, you distribute all the space equally outside, along the head and tail of the chain, but the space between the chain is set to 0. There's practically no margin. No margin, no padding. That's it. So yeah, it's all stuck together. So you guys can try out, different layouts, different settings of, the spread and pack. You can set in your app. Right, I've completed spread and chain. I'm also exceeding a bit of my time limit, which is unfortunate, but I guess I have to. So let me just give it constraints so that the error goes away. I'll change the, wait. Just, for simplicity, I'm going to change the view to linear layout. All right. Linear layout, again, I'm going to convert it to vertical one. So as you can see, I have all the views here. Now, suppose I want to work with these views, do something about them. I would create a variable called var text view 1 equals to, I'll use the function called find view by ID. I will specify what type of view it is. It's called text view, so text view. Then I'll type the ID of the view. So that's r.id dot. I think it should be text view 1, right? So now, suppose I want to set the text of text view 1. I would do text view 1 dot. Instead of setting the text, let's say I want to get the text. So I'll do var get text 1 equals to text view 1 dot text dot to string. So what it does is it gets the raw text present on the view and it converts it to a string, and then it stores it to get text 1, which is a variable. So now say you want to do this for all, all the views present on your app. Let me get activity main back. So yeah, I have 6 text views, and in order to get six text, text strings, I'll have to do the same thing over and over 6 times. So, in terms of app functionality and speed, this tends to slow down your app quite a bit. So what you want to do is use the term of view binding. So to understand view binding, it's basically you use one variable which loads all the IDs of your views at the present in the XML file at the beginning itself, and once it's all there, you keep referencing to the binding variable. So by default, you call it binding, and you keep referring to it. So you say binding dot view ID, and you'll get the view. So to show you its implementation, I first have to enable, view binding. So I'll go to Android build features. I'll say view binding true. So since I've changed my Gradle file, I require it to sync again. What's this? The problem has occurred in the app. Can I not build the app? Rebuild project, let's see. No signature method is applicable for Android. Alright, that's a strange error. I've not encountered this before. Let me explain view binding in another project. I'm not sure, and I don't really have the time to do it. So Shubham session 2. I'm hoping you guys were there for the Android overview, Android Studio overview. I'll just go back to app. I'm gonna say features, say view binding true. Oh no, wait, true. So let's see. It says Gradle build synced. I'm going to change again. I'm going to change it back to convert. Never mind, not that. Convert view to a linear layout. I want a bunch of text views, so I'll just drag and drop them for now. 3 should be enough for the explanation. Give it text view 0. Right. This is called text view. This is called text view 2. Fine. So all my text views have an ID right now. And right now I want to do something called view binding. So to enable view binding, I will first create a variable called private latent binding, and the class will be the same as the activity name. So it's activity main binding, right? So should be good. Shouldn't be an error, but all right, I'll just ignore it for now, I guess. That shouldn't be an error for me. Let me close this project because I want to be working on it. Internet where I don't see where I'm going wrong. All right, I'll just continue. Binding. Binding equals to activity main binding dot inflate layout later. So at this step, I'm basically getting all the view IDs and storing thing in binding. And finally, the last step I want to do is binding dot root. So binding dot root refers to the topmost view in the current we call XML file. So here it's activity main.xml. Still don't understand why latent can't be used. It should be correct. Anyway, I'm running out of time, so I'll just skip ahead. What I want to do is, wait, isn't there any way I can fix it? All right, in order for it to work, I need to actually remove this error, but I don't have time to debug it. So what I will do is pull out a previous app that I have built with view binding. Right, Android Stage and session 1. So it is actually similar to, it's actually very similar to what we have done today. And right, let's go to, oh, come on. Right, so the idea behind view binding is, you use only a single variable to reference all the text views or all any of the views present on the layout, and by doing that you save a lot of time. And finally, styles. So this is again something we covered in the last session, but styles refer to just a single view. Coming back over here, so if I apply a style, it'll only apply to text view 2 or text view 0 or text view, just text view, but it will not change the look and feel of the entire app. In order to change the look and feel of the entire app, you'll be using something called styles. So styles is something you apply to the entire app. So as you can see here, we have material dark theme and a material light theme. And you will notice a subtle difference that the text color, the font color is white here, but in material light it's dark. So theme is something that affects all the components of a app, whereas style affects only just that specific theme. And yeah, that's pretty much what I was supposed to present today. Sorry about suddenly disconnecting in between. I'm not sure why it happened or how it happened, but yeah, thank you. And yeah, I think Irfan can go ahead. Sorry about the extra time.
Thanks, Shubham. Hey guys, sorry about the issues today. We seem to be having quite a few of them. So I'm going to be covering Unit 4 and Unit 5 of the prior programming. Under the prior programming track, there's Unit 1 and Unit 2. Unit 1 is being covered today. Under Unit 1, there are 5 subsections. I'll be covering the 4th and the 5th subsection, which is navigation and activity and fragment life cycles. So let me share my screen here. Okay, all right. So let me start off by creating a project, and I'll be demonstrating these components via my project. So going back here, again, I'm going to create my empty activity, name it, let's call it Android Study Jams Session 2. We can save it wherever, Kotlin. Again, we're selecting our minimum API of, let's say 21, finish. Since you want to use these new features such as navigation and fragment lifecycle methods, right? There are ways to use them in the older versions of Android, but the way you use and access these features is completely different as you use Android X and the higher activities. So let me start off with navigation now. So essentially, navigation components are components that let you navigate through views or UI elements of your Android app. So that means displaying different screens, displaying a screen on top of another screen. For example, a dialogue or a fragment. What do I mean by a fragment? I'll explain that in a bit. So these are different components that can be used to display items on top of other screens. So let's start off with our basic example here. Let me just maximize this. And while this downloads and builds the new Gradle model, let's give it a minute. So already in the previous session and as covered by Shubham, there are components by the name of layouts. Layouts define the main user activity of the look of your application. So over here, again, you can see that we have our activity main. In this application, our objective will be to have another screen that shows up on device. So let's go into our res section here and then layout. Here you'll find your main activity. So the first thing we'd want to do is we want to add another layout. So for that, let us go here, and this is right click layout, new layout resource file. Let's make it fragment activity. And let's click OK. All right, so inside this, let us display a text view that says content, I am a fragment. Okay, so now, as you know, this is a constraint layout, so we'll have to attach it to the ends of the screen. So let's attach it to the ends of our screen here, and now we have it centrally placed. Okay, so that is our layout. So the next thing we need to do is we need to create our fragment. So in order to do that, let's follow the binding example. So previously, Shubham talked about setting up binding, right? Activity binding. So let's go ahead and do that. So in order to do that, we are gonna first, let's head over to our Gradle scripts. All right. And then in here, give me a minute. Okay, so in our module app, we are going to go and set up build features, build features, and now we're going to need data binding true. Let's sync this. So now that is synced, we had to head into our activity main again. Inside our code, we need to wrap all the elements that we're using into layout tags. So it's going to be our layout here. Let's cut this, paste this in here, and this is our layout component done. After this, we're going to move our namespace declarations here. All right, that is done. Now what we're going to do is rebuild the project. Similarly for our this thing, I think we need to do that the same. So let's just set that up right now. So this is your basic data binding setup here. All right. So now we should have our activity binding ready for access. So let's do it down here, private late init var binding main activity, what's activity main? Activity binding. That's importing our main binding object. Now inside here, we're gonna do this binding is equal to data binding util, data binding util dot set content view, setting it to this, and then we're setting out our basic layout again, layout dot activity main. Okay, so this is going to be our binding setup. And now, before we head into the fragment activity and set that up, let's talk a bit about activity lifecycle. So this approach would allow you to understand the life cycle better and would also allow you to understand how fragments work as well when we start working on them. So let me start with your basic lifecycle methods. So in Android, whenever you create an application, there are a set of life cycles that are followed. So an example of those would be right here. Let me just search up Android lifecycle, and that will give up a couple of hits. Okay, let us open up any image over here. All right. All right. So in this image over here, you can see a list of functions that are here, and this basically denotes your activity lifecycle. So lifecycle is the way an app runs in your Android device. So already you would have noticed that on our applications always have the onCreate function. That's what we've been using so far. OnCreate is your fundamental class. This is what determines what happens when the application is created. So when you tap the icon and the application rolls up, OnCreate is called. So here you can see that when the activity is launched, that is either it could be through a button press, or it could be you navigating to a new page, or it could be you pressing your app icon. First thing it does is calls onCreate. After onCreate, it calls onStart. So onStart and onResume. OnStart isn't always, both of these have a complicated relationship. You can guarantee that onCreate is called every time an app is cold started. What do I mean by cold started? By cold started, I mean that the app does not have an instance of it running. For example, let's say you have an application. Let's say you have YouTube running in the foreground, and then you navigate to another application. And then when you come back to YouTube, you will find that your device has paused the video at the point where you've been using it, right? So in that case, onCreate is not called when you open it up the second time. What happens is onResume. So onStart and onResume are called over here. That is because your application instance has not been destroyed. And until it has been destroyed, it will not call onCreate. So onCreate, then onStart. So this entire life cycle is for an application that has cold started. So onCreate is called, after which onStart is, and then onResume is. These two are just you could say a form of boilerplate activities. These are useful when you are performing certain operations, but in a base case, not needed. So you can assume that both of them are the same. Now, what happens is that after this, you see your activity is running. So this would be your main activity that shows up. So after this activity running, once your activity is running and on your main screen, let's say you navigate back or you go into another application. What happens is your on pause happens. That is when another page comes up or another, for example, what we'll be doing later on is your fragment. So when let's say a fragment comes up, your activity in the background heads into on pause. So on pause is when your application is, you could say, placed on a stack where it's ready to be stopped. Now, once this activity has been removed from your view, it is not visible at all, then onStop is called. Now, when onStop is called, the app can either be killed if, let's say, your mobile phone is running out of memory, or it can just stay in that state, and then on restart is called when you navigate back to the activity. Now, let's say you just clear RAM from your device, right? That forces all applications to run on destroy. And that is the application completely shutting down. So that is your basic life cycle in short. So now let me give you an example of that in our code. So jumping back here, we're going to be running the basic version, right? So what we want to do is identify when an application is entering a state. So now let us write all the core functions. So I'll just right click, generate, override methods, and then here you'll find a list of all the functions that are there by default. So what we'll be looking at is on start. Then we're going to need, so I'm going to use this shortcut from now on. So we'll be alt insert override. We need on resume. Let's call let us call on stop as well, and then let us call on destroy. On destroy. Okay, so inside all of these functions, let me just log out what's the operation that's happening. Let me name my tag DSC, and then on start called. Similarly for on resume, on stop, destroy. So on resume, on stop, and we have on destroy. So let me just create my emulator and start that up. My mic might mess up here. So over here, wait, unresolved reference data binding component. Hold up. That should cause an issue. All right, so we're going to be installing onto our device here. Yeah, so let's head into our logcat here and debug. Our tag was DSC. Yeah, so you can see that on start has been called. Oh wait, I haven't put a tag for on create. So let me just put that real quick. On create called. So let's just stop that activity, restart it. So now you would see on create, on start, on resume has been called. So let's say I press this button. On stop has been called. So my activity has not been destroyed completely. Now when I navigate back, on start and on resume are called. You can note that on create is not called. Still this activity is already in memory. Now if I go up and remove this from memory, you can see that on destroy is called, and that's the end of the application. Now if I go up in here and if I run, where is it gone? Yeah. On create, on start, on resume. So that is your basic activity lifecycle. Now what we're going to do next is we are going to try and get our fragment built. So our fragment is what's going to be displayed on screen, and that's going to be your second activity that you could call. So let us go back here. We have our fragment in here. The next thing we need to do is create an activity class that binds it. So another Kotlin class. Let's call it frag. All right, so for our fragment, we want it to be or rather, let's just, instead of having it created this way, what we can do is this in here, new, it should allow us, yeah, instead of having to manually type in all the functions and the boilerplate code, what we just do is we just go ahead and select this. So right click new, or right click the package name, new, fragment blank. So now let's call it blank fragment. Our fragment layout name has already been defined. So, okay, let's click finish here. All right, and then inside here, what we're going to do is change this to our frag activity. Okay, that's done. Now you can see there's a bunch of code that is generated for us. So these are basically functions that are typically used in fragments with more extensive use cases. So when you want them to have particular activities, particular functions, when you want to transfer data to and from them, that is when you have all of these in place. So now in here, we have our basic on create view. Yeah, you can notice that a fragment has this new function called on create view. You already have an on create. On creates are there for activities. On create views are there for fragments. All right. So now what we're going to do is we have our inflator being set here. Since we don't have any data that we are displaying or any buttons that we are interacting with in this case, we're just going to leave it at that. We don't need view binding per se for us. So let us go back in here And then what I'm going to do is in our activity main, let's have a button that lets us start up the fragment. So drag and drop a button, let it be button, call it start fragment. Again, we got to anchor it. All right, so it's anchored. We have a button set here. Now what we're going to do is we are going to add the fragment in here. So when we want a fragment isn't exactly an activity. So let's say if this was another activity, right? It would mean that we have a new screen that opens up and this would lead to a different screen altogether. A fragment is a screen inside a screen in a short form, you could say. So let's go here, and now you can find that there's a segment called fragment. So let's just drag drop it here. We want the black fragment. You can see that Android Studio automatically selects the fragment that you have. Click OK. And now we're going to go to code. Oh no, let's just anchor it first. So it's going to be here to here to here to here. Okay, that's where our fragment is going to be displayed. We don't want our fragment to basically cover up the full screen. We want it to be fit inside certain dimensions. So let's just make it 200 dp by 500 dp. So that means that it's going to cover this much of my screen space. Okay. So now this is done. What we are then going to do is run the application. So let's go back here, run, open up the emulator here. You would note that the button has not been linked to any operation. So you can see that I am a fragment shows up here. Let me just color it a little different so that it's more clear. So background tint, let's set it to black. Okay, let's just set background now. The color won't be visible. So let me set it to black, and I can set the text to white. Text color. Yeah. If we do this, should be visible. I'll design here and see what's being. Yeah, text appearance. Okay, might as well change this color to something else then. Let this be. Let's keep this as yellow. So let's take this hex here. Go back here, paste this in. Yeah. So now we have a yellow background, and then when we run this, you will notice that yeah, there's a fragment. So that is basically another activity being displayed inside your activity itself. I don't think we need the button in our case, so might as well remove it. I'll just comment it out. Control / is what you can use to comment it real quick. This has to be anchored again. So let me anchor it to this and rerun this. So there you have a fragment. Now in your fragment, you'd want to know the lifecycle methods and the accesses it has. So what we're just going to do is go back here, copy this. I'm going to paste this. Again, you will see it has the same names. Let's have the tag to be different. Let's say FDSC. All right. And now if I run this, terminate. Okay, so you notice that on start and on resume are called. If I just make it, yeah, DSC, you now note this order in which it's created. So you have your base fragment created first. Base, not fragment, your base activity. After which your fragments on start is called. So So over here, you notice that your on create, we haven't defined it inside here. So we just, if you just copy this line in here, it will give you your on create as well. And might as well have another example for on create view. Okay, so terminate. And yeah, so there you can see that we have our on create called for our activity, after which on create is called for our fragment. As soon as on create is called for your fragment, at the same time you'll notice that your on create view is called. Both of them are called almost at the same time. You can see that by the timestamps that they have. In milliseconds, it's even the same. After which the on start for your fragment inside is called, after which your on start for your activity is called. And then on resume for the outer activity and on resume for the inner fragment. So these are a little funky. They don't exactly function the same. They don't exactly function in order as you'd expect. There are different ways in which it's loaded, and there's a different way in which it's resumed. So these lifecycle methods, they're not just things you need to know. They're very useful in cases where you need to, let's say, save data, or you want to have an application run something in the background. For example, let's say whenever a user closes your application, you want to make sure that data is saved. So what you would do is, whenever onStop is called, you would run a function that ensures that data is saved before onDestroy is called. So when you call a function inside onStop, it will make sure that that function is executed before onDestroy is called. So that's something important that you can keep in mind. Again, when we close it, you can see that onStop is called. Similarly, when you destroy it, onDestroy is called for both. So that was essentially your basic introduction into fragments and lifecycle methods. Now, on the Google, on the code labs that we have provided in our links, you can access more uh, code labs that are provided by Google. Complete them, and you can get badges. And these skills that you learn via your code labs can be used in order to improve your skills and also work on the final application that you have to build in order to get your certification. So that is my part for this lecture complete. I'll be handing it back to Devansh to wrap it up real quick.
Yeah. Hello, guys. So sorry for the internet breakdown. So there was just one part left for me, and this was the lifecycle part which Irfan was just explaining. So I'll show you this with the help of an app in which every time that method is called, a toast is displayed on the screen. And I want you to follow through the flowchart as I'm going through the app. We'll wait for the Gradle build to finish. It's taking time. Yeah, it's done. So this is the life cycle of an activity which we are discussing here. And if you can just read through this flowchart which is there, I'll be going through it with the help of an app also. Just a sec. So what happens is, when an activity is launched, first the onCreate method is called, and this is a mandatory method to call. You cannot skip this, and you will always find it there in your default app. And so what happens is, after onCreate, just after it, onStart is called, and then sliding it down to onResume, and then the activity is in the running mode. So after that, what happens is, if we push the activity in the foreground, the onPause is called. So I'll show you it to you with this app which I've made, which is the lifecycle method. So you can see that onCreate toast is there, then onStart, then the onResume, and then the activity is in the running state right now. Now what happens if I push it into the recent apps this thing icon? So it goes on to the onPause, then onStop, and then yeah, just the activity is not displayed in the foreground right now. If I open the app again, you can see that it goes on to the on restart, and then on start, and back to on resume, and the activity is again in the running mode. And if I tend to close the app now, it will go on to the call to on destroy method, and you can see that, yeah. So I'll open the app again, and then I'll close it once. On create, on start, on on resume, activity is in the running mode. Then if I close the app now, on pause, on stop, and then on destroy. And in case if you're wondering what this when the flowchart will follow this part, it's when you call an activity over an activity. This is when and when you come back to it again, it will call the on resume again. Yeah. So this was all about the lifecycle methods. So yeah, so we expect you to finish all the code labs, and then as Shubham mentioned earlier that we need some apps from you guys as well, some just the basic ones. So yeah, we all hope to see you guys getting all the batches in the your developer's profile. That's all from my side. Yeah, thank you.
Okay, guys, that is all that we have for the session today. The next session will be held soon, and we'll be sending out links for that. That will be covering Unit 2 of the advanced program of the prior programming experience track, and that covers more advanced Android components, just databases and stuff. So that will serve that unit that course will serve as your introduction into advanced Androids and will allow you to make applications that have various functions and features that could be used. So thanks and see you in the next session.